Hello. In this module, we're going to be going over manipulating data with loops in both Python and Postman. Our objectives for this module are going to be an introduction to Cisco DNA Center Always On Sandbox that's available on the internet. We're going to take a look at that and its documentation that comes with it. We're going to look at storing dynamic variables with Postman using Postman tests so that we can use that API call key that we did in the previous lab and pass that to get more data from Cisco Always On DNA Center. We're going to convert the API call to code with Python. I'm going to introduce you to the pretty print module that allows us to see data a little more pretty for the human eye. We're going to look at parsing through lists of dictionaries with Python because that's a very big use case when doing API calls and scripting against something with an open API. We're going to look at coding loops with Python and accepting user input. And finally, we'll get into creating GitHub repositories so you can create a GitHub repository of your own. An overview for this lecture is we're going to be going over the API documentation for Cisco DNA Center Always On Sandbox, Postman tests, parsing through the data, loops and conditional matching, accepting user input, GitHub repositories, and I'll be doing a demo throughout the entire lecture, and finally we'll move into our summary. API documentation, why is it so important? Really, you cannot write API calls without the documentation. They're so critical to writing API calls that some companies actually even have those under a lock and key in which you have to purchase a license in order to access their API documentation. Typically, a Google search will give you the results of any API documentation that you're looking for. But again, some are not published, some you need a license in order to look at. An example of a free one is Cisco DNA Center Always On Sandbox. We can look at that without a license. So it really teaches us how to write our API calls, the different parameters that each API call accepts. It'll typically give you some examples, some example responses. It always gives you the path URI that you need to be calling and any additional header options that you need to send with your API call. So now that we know that we have to use API documentation in order to write our API calls, you'll see I came into Google and I simply just did a Google search for Cisco DNA Center API documentation, and here is Cisco DevNet's website. So I'm going to click this, which takes me over to DevNet and DNA Center's API documentation. You're going to hear the term northbound and southbound, and I'll cover that in a whiteboard session in just a moment, because it is important to know. Northbound would be kind of your interaction with the API, because it's going to you. If you draw this out, you can kind of see where they were going with northbound and southbound. And then southbound would be the API call that DNA Center is making to the actual networking devices. Because that's what all this is about, is APIs talking to different APIs and systems talking to different systems, which is what drives automation. So I'm going to click this Cisco DNA Center version 2.1.2 API. And if I go to the overview, you'll see it says the version. If I click on API, it opens up all of my options. So the first one is our authentication API that we've been using to retrieve a token from Cisco DNA Center. So here it gives a description of what it does, the HTTP method that you must use to communicate with this API, the path URI, and then here it goes over the different parameters in the header, such as content type and authorization. And then here you can see it's expecting a status code of 200, which would be a successful token generation. Here's an example body, token equals string, that is the return response example. And then if you look over to the right, Cisco's did really good with their API documentation. So here is the parameters, and I could actually run this right now. But if I want to go to template, you can see here it is for curl, Python, and Node.js. So here's the example if I wanted to pass this into a curl call from a Linux command line. Or I can click on Python requests and it gives me an example of the code that we would need to enter to run a Python script to run this API call. So you just heard me use the term north and southbound API, and I did want to kind of quickly cover what that means because it's a term that's used when you're looking at API documentation. So I'm going to draw, let's say we have the end user or the engineer behind this machine, and it's communicating on the northbound API of, let's say, Cisco DNA Center. Because what it really refers to is when you draw it out like this, that kind of depicts your north and southbound and just really gives you a better view of it. So Cisco DNA Center would be communicating with, let's say, a bunch of layer 3 switches. And it would be doing it on its southbound API, because when you draw it out like this, this is kind of its southbound, and it would be communicating things like RESTconf and netconf, which are just standards, kind of like JSON or XML. It's just kind of a it's a way for a software-defined networking controller to communicate with the routers and the switches, because they don't understand. You got to remember that the command line output to the screen, that's for humans. So because machines don't really understand that really well, we had to come up with RESTconf and netconf, which is just a way to communicate the information such as switch updates, routing protocols, things of that nature. Postman tests. We're going to use Postman tests to store dynamic variables, which is all we're really going to be using it for in this class. It's written in JavaScript, but JavaScript experience is not required unless you want to write more advanced tests in Postman. But for the purposes of just understanding tests, all we're going to do is take the results of our API authentication API call, in which we get a token returned, and then we're going to store that value in a dynamic variable in our environment. Code readability is required though, so if you look at the JavaScript code that we use, it is a pretty good idea that you should kind of understand what's going on. Even if you don't know JavaScript full, it's pretty somewhat self-explanatory. Stores return values in dynamic variables, and the use case that we're going to be using is our API generated token from Cisco DNA Center Always On Sandbox. Here we have Postman pulled up, and I went ahead and pulled up our Authenticate API call that we used in module number 2. And just to kind of go over it again, you can see here we're sending a post request to this URI, and it's pulling from our SDN environment. And if I click the I here, you can see I have my variables and their values. Note that in token right now I have no initial value and no current value. So I'm going to go ahead and run this API call, and what I want to point out now is the tests. So if I select tests, I have this JSON code where I am creating a variable called JSON data, and it's going to parse through the response body from the Authenticate API call. And then it's going to run this Postman set my environment variable token equal to the JSON token output from the body. Here you can see I have nothing in my body right now. My authorization is filled in, as well as my authorization here. So I'm going to go ahead and run this. And here you can see my returned value and tests. Let's see if it ran correctly. Now I have a value for token. And I can now send that value using the getDevices API call, which pulls the same variables from our environment variable. The difference is now in my headers I have set this xauth token parameter equal to my token variable. So I'm going to send this request, and here you can see my response body. It is important here to note that these are curly brackets and these are square brackets. So it starts with a curly bracket and a key, and the value of the key is this list, which is a list of all the devices. Here's one device in a dictionary format, so it is a list of dictionaries. There's 1, 2, 3, and 4. So this is where going through lists of dictionaries is going to come into play. Now that I have tested both of these APIs, what I could do is come over to code, select code, Python requests, and I could pull the code for Python right here and use it or dissect it to continue working on my coding skills. And I could compare that with the authentication code as well. And that is how we are going to use tests in Postman to store dynamic variables. Loops and conditional matching. It's very important to remember that we have things that we can match on. So we'll have Boolean values, which is either it's going to be true or it's going to be false. We can use calculated values because Python does basic math in which you need to apply your normal mathematical order of operations. But a little bit of basic math does help with writing more advanced scripts and code. The different types of loops are for, while, and if, then, else. An example, if we wanted to write a if statement, we could test requested data. So if a variable is equal to, let's say, an integer, or the length of a list is equal to a specific integer, then it would do something. You could do a continue of a function. So while something is perhaps true, then do this. So we could, the easiest example use case for that is a simple counting script where you say while a variable is less than or equal to a certain integer, then print the number to the screen and add a 1 to the variable. So it would just sit there and count up to whatever number it is that you defined. And then we could also do conditional matching, in which we do if, then, and else statements. So if something is equal to or less than or does not equal to something else, then do this, else do this. And we're going to see examples of that in the lab, but I try not to get too deep into loops because I just want to touch graze scripting and programming, but it is important that you understand loops and that they're out there and why they exist. Your for loop would be if you wanted to go through, let's say, a list and do something to each item in that list. I would say that's probably going to be our largest use case scenario, at least for this class, but I do encourage you to practice them in the Python interpreter so you can understand them better. Parsing through data. It is important to know that we're going to be calling object names and square brackets. So what you want to do here is when you do an API call, pay attention to the returned value as it comes back in square brackets versus curly brackets, which will indicate it is either a list or a dictionary, and that's going to indicate to you whether you need to use a key value when calling that object or if you need to use its its place in the list. So pay attention to your brackets and key values. Lists use numbers, and we call items in a list with square brackets indicating the integer number. Dictionaries all use keys. Keys require a quote, and dictionaries use curly brackets. And we're going to store specific values as variables so that we can do something with those values and then return it back to the API server. To demonstrate a basic loop, I've created a list of dictionary items called devices and assigned each of them key value pairs of hostname and management IP, along with the name and the IP address. I have 3 routers total, so I'm going to write a simple for loop that prints out to the screen the host name of each device. So that would be for, and then I'm going to declare another variable called device, which is then going to take each object in the list. So this is one object, this is the next object, and then this is the third object in the list. So it's going to go through each object and do the same thing to each object. So I'm going to say for device in, and then pass in the name of my list, end it with a colon, and hit enter. Now since I'm in a for loop, it's going to expect an indentation, so I'm going to hit tab and then call the print statement to print the device variable, and I would like to print the key or the value of the key host name. So I'm going to put square brackets around that, hit enter, and then hit enter again to initiate my for loop. And there you can see it printed the host name of each device. So to demonstrate that again, you could do something like for device in devices print, and then we'll put a message in here, the management IP of, and then I'm going to put a space, quote, plus device hostname plus, and then continue my message, is plus device, and then I'm going to call the key management IP. End it with my square brackets, and then end the print statement. I'll hit enter, and hit enter again to initiate the loop. The management IP of router 1 is, and so on and so forth. It did the same thing for each device or each object in our list. And that also kind of covers parsing through the data. But when we're looking at this on a larger scale, we may need to look at it a little differently. So I'm going to actually quit out of this Python interpreter, clear my screen, and then I'm going to make a file, and it's going to be called my get device.py, and I'm opening it with the Nano text editor, which is a command line text editor built into Linux. And then for simplicity's sake, I'm just going to open up my Python script, grab my get devices, and then I'm going to grab the code, copy it. Now this is just for simplicity in the video. The idea on this lab is that you use the input and get pass function to get the username and password from the end user, run the authenticate API call, and then use the token for follow-on API calls. But I'm going to go ahead and do this just for simplicity's sake to get us started. So I don't like using the UTF-8, so I'm going to go ahead and convert that to response JSON equals response.json, and then I'm going to print response JSON. And you can see Nano gives me my options for the menu down at the bottom. So a Control 0 will save my file, Control O, file name to write, get devices pi, yes, enter. And now I'm going to exit out of this and run. First I need to create a virtual environment. So Python 3 module then, and then we'll just call this SDN3. Source SDN3. Bin activate. Now I'm in my virtual environment. I'm going to install requests. And now I will run my script, get devices. There was an error. I did not set SSL. So the error it gave me said certificate errors, which indicates to me I need to set verify equal to false so that we will not be verifying the certificate from Cisco DNA Center. So I'm going to go ahead and write that out. Save, write the file name, and let's run the script again. And there you can see it actually gives me the response, but I can't read it very well because it's all cluttered. So I'm going to go ahead and open up Nano again and open up my script and introduce the pretty print. So I'm going to import, actually I'm going to do a from pprint import pprint, which stands for pretty print, and then instead of print I'm going to pretty print it to the screen, and then I'm going to save my file and exit out. Now when I run this time, it is not going to work, and you'll see it's going to give me an error, but it is important that you start interpreting what the screen is telling you. So there it says import requests, no module found for requests. That's an incorrect error. Get devices pi. I'm going to go ahead and exit out. Yes, save. And now I'm going to go ahead and pip install pretty print. Find a version of this. Oh, maybe it's already installed. Huh, very interesting. I wonder if it's missing the I think it's. Save it and Python get devices pi. I don't know why it ran it the other time. So, as you can see, there's always a little troubleshooting when it comes to coding, because it's so syntax sensitive. So I was just missing my S in the import, which is what it was telling me. I thought it was going to tell me that I was missing pretty print, but I guess that's, I thought that was something I had to grab, but I guess it's already installed. But here you can see we have our body that was returned back to us, and it starts as a dictionary with the first key being response, and then the value is a list of all the items. So to apply what we just did, I'm going to go ahead and go back into my get devices script. And I'm going to make this for loop. So I'm going to say for device in, actually I got to call the value first. So I need to make my devices list, or my devices list is going to be equal to response JSON, and the key, which was, let's go ahead and verify it again. Oh, I'm sorry, it's response. I'll write this out. I'm still going to need to verify because I'm not sure if that's what it was, but we'll check on it. Yes, so it is response. So now we've called that key, and the value is going to be the list of all these devices. So if I do nano get devices pi, now I've got my devices, and instead of pretty printing everything, now what I'm going to do is put a for loop in here, and as you can see from here, all I did on this was put this pound symbol which comments out that line. So we're going to do for device in devices print device. Write that out, save it, exit, and let's run it again. As you can see, it printed everything, but it did it not very pretty again, so let's call pretty print instead to make that more readable. Save it, get out, and let's run it again. And there you can see it pretty printed everything, but now instead I do not have that request or response key anymore, because now I am printing each item in our list. And I can even keep going and call different items from in here. So for instance, we can look down here at the role, or you can grab the MAC address, the management IP. For instance, let's go ahead and do the platform ID. So we will print just the platform ID on all of these. So I'm going to go back in, nano get devices pi, and instead we're going to pretty print platform ID, close it off with my square brackets, exit, save it, run it again. I'm still using pretty print, so I cannot do that with pretty print. And do get devices, fix that, save it, run it again. It was platform ID, correct? Device. Oh, the D. I said syntax is everything. So run that again. And there it printed the platform ID of all 4 devices. So that is your Python example of loops and parsing through your data using loops. I hope you enjoyed. Accepting user input in your script, this may be something that you have already been thinking about, because you may need to ask the user to do something or enter in an object. For instance, you could say that you could ask the user to how many decks of cards would you like to draw from the deck of cards API on the internet, and then use the value that the user inputs, and that would give you the value that you want to send to the API server, indicating how many decks of cards you want to draw. The most common use case for this is when you start doing a lot of scripting towards vendor products and appliances, is using the input module to call for things like the username and password, which is how we're going to accept input from the user, is by calling that input module. Passwords, we do not want to use the input module, because as you'll see in the example, if you use the input module, what you type is displayed to the screen. If we did passwords this way, that would make the screen vulnerable to shoulder surfers who look over your shoulder while you're typing in your username and password, or screen crabs that could grab whatever it is that's displayed on your screen and export it to a storage site off-site. So to do passwords, we are going to use the getPass module. We use the input and getPass module to store the values as variables and then pass those variables to things like authentication or API calls. And we can use the input and getPass function to display a message to the screen letting the user know what it is that we need from them. To accept user input in Python, we are going to call the input function, and I would say the easiest use case or analogy to use for this would be accepting a username and password. So I'm going to declare a variable in my Python 3 environment, and I'm going to call it username, and it's going to be equal to the input function, and I'm going to hit enter. And you'll notice it kind of stalls right here. Well, this is because I haven't given it a message to print to the screen, so it's waiting for me right now to enter something. So I'm going to go ahead and just put my name in there, hit enter, and now let's go ahead and print username, and you'll see it's set to my first name. So to actually make a message appear, we're going to set username is equal to input and enter your username. Put a space, close it off, hit enter again, and you can see now I have a message. So I'm going to go ahead and put my first name in again, hit enter, print it, and you'll see it took it as my name. Now this does not work well with passwords because, as you can see, when I put my username in, it printed what I was typing to the screen. So in order to get around that for passwords and protect our passwords from shoulder surfers, we would want to import getPass, and then we're going to call it, setting the environment password equal to getPass, hit enter, and you'll see it's asking me now for my password, which I'm going to set to you cannot see. But if I print it, you can see it printed my password to the screen. And the same goes for getPass. We can do password is equal to getPass, and then we can print a message. Close it off, hit enter, and it says enter your password now instead of just password. Enter, and now I'm going to print again, and since we couldn't see it on the screen, I went ahead and changed it a little bit and put password 2. And that is how you accept input from the user in Python. To create your own GitHub repository, you can do that through the graphical user interface on the website, or you can do it from a local command line, and we'll kind of briefly go over both ways to do it. It is not difficult. You do need to remember that your GitHub repository, let's say you actually became a full-on DevOps engineer or an automation engineer and got really into coding, your company could have a local or a remote repository. It just depends on how much coding it is that you're doing and how many people need access to it. Your code can be private or public, so if you are working on code for a specific customer or on a specific project that you don't want other people to have, you can make them private, or you can make them open source and public for other people to work on. And again, we can create these at the command line and push it to GitHub, or we can use GitHub to initialize and clone the initial repository. Using GitHub repositories allows you to work on code on the go from anywhere, as long as you have the necessary tools to work on your code on the machine that you're working on it. And to create personal repositories on GitHub is free. It does not cost any money. All you have to do is create an account. You can use GitHub Online to create a free account and also host your own repositories, and I'm going to teach you real quick how to create a GitHub repository. So here I can come over and I'm signed in. I've selected repositories, and then I'm going to select new. And I'm just going to go ahead and call this one test repo. I'm going to make it public, and then I'm just going to go ahead and leave default values and click create. And here you can see it gives me all of my options on how to actually create it. So I'm going to go ahead and create this one from the command line. But I would say my favorite way to do it is just to initialize it with a README. Like we saw on the last page, you just select initialize with a README, and then it creates an empty repository with the README. You clone it down, make any changes, and then push it back. But here you can see it gives me all of the commands that I actually need in order to create it from the command line. So I'm going to come back to our SDN VM here and pull this out the way. Quit out of this, clear my screen. And so now I'm going to go ahead and echo in a message. So I'll say testing repository for SDN, and then I'm going to pipe this output to README, and that's what that does. And now I'm going to actually, you know what, let me list where I'm at first. I'm going to make a directory for this, so we'll do test repo, make directory test repo. I'll go into my test repo directory. And now I'll just go ahead and enter the echo command again, list, and you can see now I have README there, and if I cat it out, testing repo for SDN, okay, good. So now I'm going to use the git command and initialize a repository, git with git init, and it tells me initialize empty git repository here. Now if I list what I have, you can see I still only have a README, but if I list long and all, you'll see I now have this .git directory, so I can also list the .git, because that's what the git init did, was create that hidden directory and all my configs. So I can do a cat.git config, and you can see there's my configuration. So now I've got to add everything, and I can do that one of two ways, by just saying git add and just README. But one of the ways I've kind of got used to doing it, just because this is going to make it easy, is put a dot right there which indicates everything that's in here, which would just be this README. So I'm going to git add, and then I'm going to say everything in my current directory. Now you have to commit it to a branch, and when you make a commit, you have to give it a little message. So I'll say first commit on example repo, and this is for logging purposes, and every change that you make to a repository, it's going to commit this message along with it. But we're also going to get an error right here, or I should, I'm not sure if my config still has my username and password. Alright, it does. So I committed that repo, and now I'm going to git and create a new branch for the branch master, and I'm going to git remote. And if you're still confused about branches, really a branch is a way for you to make a full copy of the code and work on a code while keeping the master branch intact, but you're making changes on a different branch. So I made the branch master because that's the master branch now, and I can make more working branches which would just completely copy the code and show me the difference between the master branch and the changes that I made. But here I've got to remote add the origin, which is git remote add and origin, and then I'm going to put in the URI for my GitHub repository. So I added that as my origin, and now I'm going to push the code to my origin's master branch. It's going to prompt me for my username and my password. And there you can see it successfully pushed to the master, otherwise we would have got an error. So now if I come back to GitHub, and these were the commands that I just entered, and I click my test repo, you will see now that I have a single README file in there, and it's testing repository for SDN, which is what I pushed via the command line. So now I have an empty repository, and that is one of the ways in which you can create a repository. Again, the other way is to simply create the empty repository, and I can actually go through that really quick. So I will go back to my repositories, and I'll create a new one. We'll call this test2, and we'll go ahead and just add the README file, create the repository. Here it is, and then I can just come in here, grab the URI, and I can clone it. I'm going to get back out of here. List, you can see it's not there. Git clone. It is cloning list, and now I should have test2, which I do. So I'm going to go into test2 list, and you can see the README file that I created up there, which all it says is test2. So that is the second way, and as you can see, the second way is a little more efficient, which is why it's probably used more common, but you do need to understand that you can push it via the command line like that as well. So in summary, we've looked at API documentation for Cisco DNA Center. We looked at Postman tests and how we're going to use it to store dynamic variables, how to parse through lists of dictionaries and call different dictionary items where it may contain a list as well. We've looked at loops and conditional matching, accepting user input with the input function and get pass. We've covered how to create your own GitHub repository, and then I've done various demos throughout the discussion. If you have any questions, please direct them towards the discussion board. Chances are, if you have a question, someone in the class has the exact same question, so I encourage you to use those discussion boards to post questions on anything that you may still be confused about. Otherwise, you are always welcome to reach out and text me. Thank you, and I hope you enjoy this modules lab.